When designing and manufacturing plastic parts, Autodesk's digital prototyping solution has you covered. We've been tasked with manufacturing the rear deck of this Vimek tractor. So, let's take a look at a typical digital prototyping workflow for a plastic component. We will need to assess the manufacturability of our part. This can easily be accomplished within Simulation DFM. To do this, we must first check out our part from the vault. With our part opened in Inventor, Simulation DFM will now assess the manufacturability. As this is a larger part, we'll need to add a few additional injection sites. After DFM has run its analysis, we can see that this part will be easily manufactured, though there are a few alerts, specifically with weld lines and draft angles. As there are multiple injection sites on this part, there's not much we can do about weld lines, so we'll focus on draft angles. All of the surfaces without draft are shown in red. These can cause problems in the manufacturing process, so they have to be corrected. Draft will be added to these surfaces, and we will run the analysis again. Draft has been added to our problem surfaces, and we can see that our alert has been resolved. It looks like we still have an alert regarding the recycle rate of the part. As this is a larger part, it's to be expected, and it won't be an issue. Now, we're ready for Simulation Moldflow. To access our study, and to prevent other users from simultaneously making modifications, we must first check it out from the vault. With our study checked out, we can now begin our Moldflow analysis. Due to the size, layout, and material specifications, this part would be best manufactured using compression molding. So, 3 charges have been added in the place of injection locations. Next, we'll take a look at the meshing parameters. As there are some smaller radii on this part, we should adjust the chord angle to a finer setting. We should also increase the number of elements through the thickness. That would give us a much better picture of interior flow. Now, we can mesh the part. With our part meshed and everything looking good, we can now review our process settings. Changes in process setting can have a profound impact on the final outcome of the part, but in this case, we'll stick with the defaults. This would also be an appropriate time to verify our material selection. Due to a customer specification, an epoxy is the appropriate choice. With everything set up, we can now start our analysis. The analysis is finished, and we can now check our results. The part took about 8 seconds to fill and has a fairly uniform fill pattern, consistent with what we would typically expect from this process. These results are looking good. Upon further review, we can see that there's some shrinkage. Though relative to the size of the part, it's quite minimal, and to be expected in most plastic manufacturing processes. The tooling will just have to be built slightly larger to accommodate for this. Now that we've reviewed everything, we can create a report for the tooling department with the information that they'll need. This can easily be accomplished by marking the necessary results for export, then by using the Moldflow Communicator export feature. With everything completed, we can now check our Moldflow study back into the vault.